Orbital Gardens, this is Mission Control. We are confirming acquisition of your signal. You are live in 5, 4, 3, 2.
Hello and welcome to episode 24 of Gardeners of the Galaxy, the show for all of the sentient beings in the universe who have a passion for plants. I am Emma the Space Gardener and I will be your host as we explore gardening on Earth and beyond. On the 3rd of June 2021, a SpaceX cargo Dragon launched that docked at the International Space Station 2 days later. On board that spacecraft were several plant experiments, some of which I talked about in the last episode. One of those experiments is Plant Habitat 04, PH04, which will see NASA growing its first chili peppers in the Advanced Plant Habitat. While Cargo Dragon was in flight, I was privileged to speak with a member of the PH04 team. I caught up with Jacob Torres on his lunch break at Kennedy Space Center. At one point, Jacob starts showing us the plant growth equipment designed for PH04, and I'll take a couple of stills from our video chat and put those in the show notes for you. And there's a little bit of background noise on the interview, but remember, that's real NASA background noise. Hi Jacob, thanks for coming on the show today to tell us about the work you've been doing with NASA.
Hello. Hi, Emma. Thank you for having me. I'm so excited to be here.
Thank you. So it must have been a really exciting experience to watch a project you've been working on launched into space. Can you give us a little bit of the history of the Space Chilies experiment?
Sure, absolutely. Emma, you're absolutely right. The experiment I'm working on, PH04, which is called Hatch to ISS, launched yesterday on the 22nd resupply mission to the International Space Station, launched by SpaceX. So it was a real exciting day because several years of work had come together and ended up on the top of this rocket. And all now we have to do is get our equipment and hardware to survive the booster separation and the vibrations to get up to the space station to start our grow out. So Yesterday was a very exciting day for us. But the history or a little bit about the mission. You had one of my colleagues and really good friends, Dr. Joya Massa, on your show.
I did.
A few shows
fabulous,
back.
Yeah.
She, as much as she's my friend, I am also just like a huge fan of her and what she does and everything she does, just so amazing.
Yeah.
And she talked about the food production mission that NASA is doing for astronauts in other environments, like when we go on missions to space, or if we go to the moon, or we go to Mars. NASA wants to supplement the astronauts' diets with fresh crops and fresh food to eat along the way. They have prepackaged meals, which are very, very good meals, but they have some vitamins and nutrients in them that degrade over time. So we had a need to make up those calories and those nutrients in one way. There's also the need to have fresh food available for the crew members as they're doing these missions. And growing crops was a natural thing for NASA to do to fill those nutrients. So before we go to the moon, before we get to Mars, we have our platforms in low Earth orbit, the International Space Station. And there we have two plant growth systems. One is veggie, the other one is advanced plant habitat. And inside them, we're able to fulfill plant growth experiments in the microgravity environment. Gravity is a big part of what tells plants how to grow, or at least they evolved that way. So the question was, will plants actually be able to orient themselves if we initiate them in space? And what would someone have to do to make that happen, to facilitate plant growth in the environment? So we're taking advantage of that by growing different plants. We have some restrictions in space, in size, and also there aren't bees or pollinators in space.
Yeah.
The crew members have many projects that they need to do on top of the plant growth. And so anything that we can do to make it easier for them or shorten the growth period makes our experiments more viable. So that means that we've grown a lot of things like leafy greens, crops that are pick and eat that don't require pollination, maybe a 28-day grow out, 4 weeks or something like that. And we've been very successful. And you can see a lot of pictures online where we've grown lettuce and pak choi, which was selected by students at Growing Beyond Earth, and just all kinds of cool leafy green crops. But ultimately, to supplement a diet for a person or for a crew, you would have to have a more diversified amount of crops to eat. And that would include vegetables, fruit, crops that flower and require pollination, and then maybe even later processed foods like flour and wheat and other things.
Yeah.
So it's a progression, and peppers came up for a couple of reasons. One, they have vitamins and nutrients that are really important to the crew. There's actually more vitamin C in a pepper pod than there is in an orange, which is amazing.
Yeah.
And then there's things like vitamin B1 and creatine, and those are just really great for the crew's diet while they're in space. But then number two, peppers can grow in our environment. It takes a very special crop to grow under an automated environment, and maybe with a periodic check-in with the astronaut or the crew members. And so you have to select real carefully the cultivar. Well, we're just real lucky that the pepper plant, you can tap the flower and that will pollinate it. And the pod itself is encasing the pepper seeds so they don't fly everywhere. And it just worked out that it grew really good in our environment. But then, which one do you grow?
Yeah.
There's all these amazing peppers out there,
Yeah.
you know? And so the team here at Kennedy went on an exploration of different peppers. And we have these growth chambers where we can simulate an ISS environment. And essentially that means high CO2. There's a lot of crew members on the space station, and the CO2 level is elevated up there.
Yeah.
So we simulate that down here, and we grow all these different pepper plants that Lachelle Spencer chooses out, and we set them up, and some do good, some don't. We're using LEDs, an artificial environment, high CO2. There's all of these treatments, and some pepper varieties just don't like that. You can see the intumescence that they get on their leaves. Some of them won't flower, or you won't even get fruit. But there were a select few that grew really well under the LEDs. They're like, we don't care. This is great. The ones that grew well, one of them was a Bulgarian carrot. It grew excellent.
Uh-huh.
But Bulgarian carrot was so hot that it could have been a hazard if it was floating in space.
Yeah.
Pepper mace.
Yeah.
Another one that did well were the Hatch peppers. Hatch is a town in New Mexico where they're known for growing their peppers. It's actually classified as a sweet pepper, but it still has some spice to it. And those grew really well. And that just happens to turn out that I'm from New Mexico. So when I came in as an intern in 2018, and they were talking about Hatch, and I go, there's a town in New Mexico called Hatch. And they're like, yeah, we want to grow peppers from there. Really? So I got into the conversation as an intern about New Mexico peppers and which is the right variety to grow. The New Mexico Big Jim is the famous pepper from New Mexico, and that's the one that has all the publications and other things that led NASA to New Mexico.
Right.
But I got to sit in the room and say, hey, I'm from there, and I'm actually from the northern part of the state, which is still in the Rocky Mountains. It's next to the Colorado border, really high. And then Hatch is down south, and it's a lot lower elevation.
Yeah.
So winter comes sooner in northern New Mexico, which means the peppers that are there, they have to ripen and fruit faster. So I just recommended, if we want to reduce on crew time and the amount of time to grow the pepper, maybe we want to grow a northern variety. And that was kind of my first contribution. We started to explore hybrids from Big Jim and Espanola mix. And ultimately it turned into this one plant called the Espanola Improved that served our purposes. And that's what's glued to Wix right now and is flying up to the is flying still up to the International Space Station.
Yeah, I say at the moment that we're recording this, it's literally sort of in orbit around the Earth, and it will be docking on the ISS. They say sort of early tomorrow morning. I think that's your time rather than mine. So yeah, that's amazing.
Around lunch your time, I think, right?
Yeah.
Yes.
How cool is that?
How cool is that we have to consider that in our conversation?
So, we're on the move.
Oh, yeah. I'm in my lab. This is my makerspace. I have my 3D printer here, and these are our labs.
That's amazing. Yeah.
And those are our environmental chambers back there, and we grow all these different plants and stuff back there. And everything starts here. We grow them and try to make mistakes and do everything that we can to learn how to grow the crop in these chambers first. And then eventually it gets to the point where it's on a rocket and we're flying it to space, so.
Okay, so you personally, you have an engineering background. How did you become interested in growing plants in space?
That's a great question. I had never thought about it before, or it even occurred to me that growing plants could be something that I could do for a living.
Yeah.
Of course, I grew up in a traditionally farming town in northern New Mexico called Espanola. For centuries of my family lived on the same piece of land where they farmed, and that's how they lived. I wasn't raised a farmer, but I gardened. I guess you can call us like ranchers, where we have this land and we maintain it. But I always grew plants, but I had equipment that we needed to work on as well.
Yeah.
So just in my mind, being an engineer and building the equipment was a way to make a living. The plant growth that I did was just for fun, something that I did as a passion. So I went to school. When I left home and went to New Mexico State University, I found myself in a dorm room, and I missed the plants. I missed nature and all of these things. And so it wasn't long before I started finding ways to bring them in the house. I would grow some plants back here and some back there, but every dorm room is literally 200 square feet.
Yeah.
And if you're spreading your plants out, you don't have too many, but if you can make them vertical on a wall or something,
yeah.
you can have so much more. So by the time I got to Purdue, that evolved into a plant wall. It's a wall that has all kinds of plants, and then I have lighting on it. I use
amazing.
Alexa to turn, Alexa, turn the lights on. Alexa, water the plants. So it's controlled by Alexa, and I did these plant wall things, but it was just fun. My master's thesis was on this technology called the BioWall, which is a botanical air filter. It uses pipe mediation to filter VOCs out of the air. And so we built this chamber that has lights, humidity, controls, and all that to grow the plants in it. But its purpose was to filter air. And when I applied for an internship at Kennedy Space Center, Joya Massa and the team saw that on my resume, and they said, hey, this is kind of what we're doing.
Yeah.
But instead of filtering air, we're growing crops. And I said, great. I took an internship over here. That first internship went well. It turned into a second one, and then I never left.
Amazing.
I ended up with this full-time position working here. I did not know about this team before I started working with them, and I was kind of embarrassed about that. But so it's just really, it's something that I feel like I've spent my life training for.
Yeah.
And I had no idea that's what I was doing. So it's
That's
just
a fantastic
amazing
story. Yeah. That's brilliant. Okay, so with your engineering background, can you tell us about some of the technical challenges of growing something like chilies on the International Space Station?
Sure. Oh, yes. The biggest part of my contribution to the team is the engineering aspect. We have, of course, the NASA team, Matthew Romine, who is the PI of PH04, and he has a biology and scientific background. Then Lachelle Spencer is a lead horticulturist, and she focuses on the horticulture. But we've never grown chilies in space before. We typically do 28-day grow outs, but peppers are going to take 90 days to get green peppers, 120 days to get red peppers. It requires a whole new set of hardware to make that happen. And there's just a lot of challenges to how do you plant the seed? Where do you orient the seed? How do you keep the seed in the wick through the launch until it gets to the space station where you can add water and initiate growth?
Yeah.
We did various grow outs, and we realized that the wicks that we were making was pinching the stem,
Right.
and that was causing stem rot. And then so some of our plants would tip over and fall. So there was all of these challenges to growing this cultivar that's never been done before. And we've come up with the configuration. We don't know how it's going to do yet, but we have a lot of faith in stuff in the testing that we have. But the reason I went mobile was to get this is actually one quadrant of the science carrier.
Yeah.
The science carrier is 4 of these in 4 sections, and then there's 3 rows in each one.
Okay.
And then these are the wicks that we had, and we designed the wicks to open up to pull the salts away from the seed, and then we plant the seed inside there. We'll use this glue called guar glum glue, which is good. It holds them there. but it doesn't stop plant growth. And so we'll glue them in place, oriented in a way that tries to direct the root down to the moisture and the cotyledon up to the light, and those types of things. And hopefully we will have given it a good chance to grow. Another obstacle is I can build this great hardware to grow these plants, but if your seeds don't grow, then you're not going anywhere. The space station has the sanitization requirements, and so seeds have to be sanitized before they're sent up there, because they can have and do have microbiology that will grow from them that could be hazardous to the crew members, like pathogens and stuff. So there was a sanitization process that went on with the seeds, and after you expose them to a chemical to clean them and let them dry after, of course, they're not as viable after. Essentially, to get ones that meet the criteria, it has to germinate at 90% to be able to be considered for flight. The team had to sanitize more than 1,000 seeds, maybe to get 100 of them that we were able to use for flight and ground control.
Right.
And so in the end, all the hardware and everything's great, but it's the seeds and how they're prepared is going to make the biggest difference in how we grow. But of course, all the pieces come together to make it successful.
Wow.
Or not.
Wow, that's a lot of work. Whenever I talk to people about these experiments and they say, we did this, we did that, it's just like, that is so much work.
Yeah. And not even mentioning pollination. Pollination, of course, we have these beautiful flowers and they need to be tapped or something. And the original intention was like, okay, the crew member can go in and tap our flowers every once in a while. Or can we use our system inside the APH to help fulfill that? And I think it was Lachelle who had the idea, well, why don't we ramp the fan up and down, the fan speed to move the flowers? So we gave that a try. And it worked great. So that's what we're going to try in orbit, is to ramp the fan up and down occasionally to pollinate the flowers and see how that grows. And then we'll find out.
Wow. So, I mean, it's not just the fact that you're growing the first chilies in space. There's a lot of things here that are like the first time and are going to be tried out in orbit. So, that's amazing. Yes. I'm going to say amazing a lot.
And the hope is, that's cool. The hope is that opens the door to other crops, like tomatoes and other flowering and fruiting crops, and then vegetables and so that is our hope. These peppers are like a good bet for a first chance, but if they go well, then we will want to try more things, and that's the whole aim.
It's so sort of mind-blowing to think of something that gardeners on Earth do every single day, and it's really simple, and the plant takes care of most of the work, and you take that into space and you think, well, how hard can it be? And it's like, really hard.
Absolutely. And imagine if there's the story of the space zinnias. In veggie they grew zinnias, and there was an issue with the fan. And some of the plants had been lost already, and we just needed to reach out to the crew to turn the fan up. But how do you message an astronaut to say, hey, can you turn that fan a little bit higher? It's a process. You have to communicate with Johnson Space Center, and they do their thing to get up to, so farming with the crew, it's hard. It's there's a little bit of a challenge to it.
Yeah. Okay. So I'm really excited to see what happens with that, and hopefully that will be sort of later this year. We'll find out a bit later on. But for the past year or so, I think it is, you've also been working on a fantastic citizen science project that is related to this NASA research. So can you explain about the Space Chile Challenge?
Sure, absolutely. Emma, thank you so much for bringing that up. I think it's so awesome. The Space Chile Grow a Pepper Plant Challenge. I chose a sentence to title my project. Yeah. But ultimately, I am from New Mexico, and we are so passionate about our peppers, our chili. We call it chili with an E, and we're just so excited. It's part of our culture and who we are. And I felt like it wasn't fair that I'm the only New Mexican here enjoying all of this chili growth, and I wanted to find a way to bring the public in, especially the people from home. It's not every day that we have involvement with something like NASA or our culture is launching up to space. We have a lot of issues where I'm from with the community and other things, and it's just really good to have something positive. And I needed to find a way to get it out there, to share it with everybody. An educational activity and a way to get everybody involved in the research, I felt like was a great option. So I was in Albuquerque, New Mexico, and I had a chance to talk to another space farmer. His name is Dr. David Hansen. He was the PI on PH01, the first grow out in the plant habitat. And we had this conversation that we're having here. And, you know, it was like, well, why don't we do a hydroponic cup challenge?
Yeah.
I was like, oh, that's a good idea. So he threw the idea out to have a challenge. And a month or so later, the Space Chile Grow Pepper Plant Challenge came out. And it's just completely a way to get people involved in the research. We've created this activity around a cultivar of seeds that is a candidate pepper crop that was given. These seeds were given to me directly by the farmer Fidel Martinez in Chimayo, New Mexico. And it closely resembles the Espanola improved that we're going to grow, but it's a candidate that we had here in the labs that did exceptionally well as well too. And so we wanted to share that and do an experiment on that cultivar and let everybody grow their plants in their environment in their own way, and then document it and submit it. And the idea is, you know, here in the labs, Joya, Michelle, and all of us, there's only so many of us, and we can only do so many grow outs. But if we can do more in different environments and under different scenarios, that moves our science forward so much more. So say we had this army of citizen farmers who are growing pepper plants around the world, and they documented that, then we could reference that to see what they did to make it grow, how it grew in, say, you know, a really high temperature, dry air place or a high humidity place, or, you know, in all these different environments. And then if they grow in these environments in classrooms and other things, then that means it has a really good chance of growing in space too.
Yeah.
So that helps us to understand the cultivar. And in one way, the public is getting involved with PH04 and growing Space Chile. And another way, the research is advancing with everybody growing. So it's just this great relationship that, you know, anybody can join. It's free. And I send out the seeds in the evening in my free time and
Yeah.
answer posts and all that stuff. So everybody is most welcome to join.
Yeah, I mean, I'll put the links in the show notes for everybody so they can check that out. But I've seen your Twitter pics of you know, mailing seeds out in the evening. There must have been, you know, you must have sent out thousands and thousands of seeds all over the world.
We're literally up to tens of thousands
Wow.
now. Packets have been made and shipped out and mailed. I'm non-funded. It's not an official NASA project. It's just me in the evenings. And it's turned into, you know, just a side project to now it's actually, we have a database with statistics going on and all kinds of everything. It's just turned into this really amazing thing. But we are in every continent in the world. Currently, Jess Bunchek is growing that Martinez Chimayo at ISS Eden in Antarctica.
Wow.
We've launched to the stratosphere 3 times in different forms in a balloon. And then there's been teachers or schools who have launched rockets really high up with the seeds, brought them back down and grown them. And there's just been so many amazing things. It's just like so wonderful.
It's fantastic. And you were kind enough to send me some seeds, and I grew a plant in my little aero garden, and I put my results in the database. And
did you?
I did, yeah. Of course I did, yeah.
Awesome.
But I mean, so one of the things you were looking for is there an environment where you can, you know, reliably make these peppers spicy? And I have to say that, you know, growing them in an aero garden, they're not reliably spicy.
And that's my problem.
Yeah.
We're like scared of the peppers because we don't know, at least growing them indoors. This is my problem completely. Growing them in these controlled environments, they grow well, they're beautiful peppers and stuff, but they haven't been hot like they are in the field.
Yeah.
And that is the main point of the challenge, is to help me learn how to grow them hot like they do. And what do we have to do to make that happen? And, you know, under LED lights, which is a fraction of the amount of sunlight that the sun would provide.
Yeah. And
different type of soil and dirt just makes them unable to grow that way. And so you just never know if you're going to pick one that's going to taste like grass or it's going to be hot. And so we're like afraid of eating our peppers, you know.
It's like chili roulette, yeah.
It is. That's a good one. I like that one.
I know that you're going to have, the astronauts are going to be eating some of these peppers, so are you going to be like sitting there going, oh?
Ooh, absolutely. I've already thought it out and everything. Oh my gosh. Hopefully it's good.
You're gonna phone in sick that day.
Totally.
Okay, so I'd say, my last question is on a less serious note, but this hasn't been massively serious so far. So, if you had the opportunity to join a community in deep space somewhere, so maybe the moon or on Mars, and you could only take one plant with you, your space chilies are already there. If you could only take one plant with you, what would you choose and why?
That is like a really hard question.
It is, Barry.
My goodness. It took me a while. I think this one of my favorite fruit are cucumbers. I love cucumbers, and cucumber plants are just so beautiful because they grow like a vine and they'll cover the wall, and then they have these beautiful yellow flowers, and then they put out this awesome fruit. So if I could find a cucumber that is self-pollinating or didn't need like pollination between flowers and stuff, I would totally take cucumbers.
Actually, I mean, you can, because my dad used to get special seeds for cucumbers that are female only, because you don't want them pollinated because that makes them bitter. I'm not a fan of cucumbers, so I've never grown them. But this is, I remember my dad sort of paying a small fortune for like 4 seeds of cucumbers that were female only. Yeah, you can have your space cucumbers without fertilization. You don't need it.
Maybe that'll be the encore to Space Chile.
But yeah, they're not small plants.
They're not. Yeah,
they're going to escape out of the APH and take over the entire, lab module or whatever.
Yes, absolutely. And so there's the other plants. We want to grow legumes.
Yeah.
And, a lot of them are known to be tall, like green beans and peas and stuff like that. But, can we find varieties that will grow within the small space of the veggie unit or the APH? And so that's one of the experiments that's going on in the chambers over here. That is our challenge of these great plants. Even the New Mexico peppers are known for being this big, huge plant. One of our biggest challenges was dwarfing them down or getting them to grow within the space. My prediction to the team when we first started was that they're going to grow up to the light, crowd the light out. All the leaves in the bottom are going to die because they're not getting light and they're going to look ugly. I warned the team, so in case it happened, they would be ready for it. Nothing like that happened at all. They ended up growing within their space. They look beautiful. And so we hope that what we saw in our ground unit, which we call the EDU, we hope that we will see that also up in space in the actual APH. So I'm just really excited.
Yeah. Thank you so much, Jacob, for coming on the show. You've been absolutely fabulous.
It's my absolute honor to be here, Emma. I listen to your shows all the time.
Oh,
You've had all of my friends on, and now I'm so excited to be one of them too. So I'm cool too now.
Brilliant. So maybe you can come back on when the peppers have grown and tell us all about that. I'll certainly be keeping an eye on when the experiment goes ahead and what happens, because this is just so exciting.
Awesome. Very cool. Thank you for watching, Emma. We're so excited that you support us and everything. So thank you.
Many thanks to Jacob for giving up his lunch break to talk space chilies. If you'd like to get involved in the Space Chile Grow a Pepper Plant Challenge, I'll put those links in the show notes for you. And Jacob mentioned some legume experiments currently running at Kennedy Space Center. I have some more information about those, which I have put in the latest edition of the Gardeners of the Galaxy email newsletter. Each week the newsletter delivers a fresh crop of astrobotany goodness directly to your inbox. If that sounds like something you'd enjoy, then I'll put a link to the sign-up page in the show notes, alongside the link to read this week's instalment online. That's it for this show. You'll find the show notes on my website, theunconventionalgardener.com, which is also home to a virtual tip jar for those of you who would like to support the show. If you want to become a regular supporter, you can sign up via patreon.com/gardeners of the galaxy to access extended episodes and bonus content. I'd love to hear your comments on the show. You can comment on the Podbean homepage, on my website, on Twitter, Facebook or Instagram, or email me, and the address for that is earth@spacebotany.uk. I'll be back in a couple of weeks with episode 25. Thanks for listening. Goodbye.
Orbital Gardens, this is Mission Control. We're confirming termination of your signal. The ground control team would like you to rerun the radish cropping experiment. Apparently, there was a bit of a mix-up with the samples you sent down, and the technicians had them for lunch. They did say to tell you they were very tasty. Mission Control out.